So, look at your question. Given that piecewise function asks you to determine whether it is differentiable or not. So, concept of differentiable means we are going to find f prime x using either of limit. Yeah, first principle. What's your first principle formula? Limit h approaches 0 for the function plus h minus fx over h. And our function getting here is piecewise function. We draw it in interval less than 1, 3 minus x squared, more than equal 1 square root x plus 3. So when we want to find the limit, they want to approaches, h approaches 0, this function we have, is it differentiable at a point? So bukan differential generally lah. Differential at a point, it will be f prime a equals to limit x approaches a, then fx minus fa over x minus a. So that is different between first principle differentiate macam biasa general dengan differential at the value point here, at the value of x here. So we are using this formula. So look at x approaches 1 here. When we get near to the interval x equals to 1 here, left hand side, right hand side is different function. So we need to find our limit from left hand side and right hand side, see whether they're same or not. If they're same, then only this limit exists. Then when this limit exists, then only we can say it can differentiate. It can be differentiable at x equals to 1. Okay, so look at this formula. What should we need? Means you need the first one is fa. A value is 1. What's your a here? You want differentiable at 1 means a value here is 1. So you need f1, coordinate f1. Where's the coordinate point f1? Fall on quadratic function or surd function? Surd function. Follow this. Why we know that it is surd function? Because it is equals to 1 under surd function. So coordinate equals to 1 using surd function. 1 plus 3, surd 4, your coordinate is 2. Okay? Then we try to differentiate value of 1 from the left hand side, which means limit approaches value of 1 from the left hand side. Okay, soalan ni kita kena pecahkan kiri kanan sebab kita nampak dekat value satu kiri kanan tu line function. Kalau satu function je tak apa, kita buat terus dengan satu function. Kalau function you tengok piecewise line function, then you have to spread it, tengok kiri kanan. So from the left hand side, function that you select will be 3 minus x squared, and the point here will be equals to 2 over x minus 1. So try to evaluate this limit. When we substitute inside, 0 over 0 IDF. So IDF in terms of 0, 0, what can we do? Yes, factorize. Since we have a quadratic function here, means we can factorize. Our quadratic here is x squared plus 1. Then when we want to factorize it, make sure you take out negative first. Then only we can start factorize. When you have a squared, or not here, a squared minus b squared, we factorize a plus b, a minus b. So therefore here we have x minus 1, x plus 1, and our factor of IDF, the value that make you IDF 0, 0 is x approaches to 1, which means that the things you need to simplify here is x minus 1. So you can see x minus 1 here. Dah jumpa dah faktor ini. You make this factor, simplify this 0, 0 IDF, then we evaluate the limit again, we get negative 2. So this is from left hand side. Then we go on for the right hand side, differentiate for the one from the right hand side, limit x approaches 1 from the right hand side function. Function is using surd x plus 3. set x plus 3 minus the coordinate. Just now we find fa, f1 is value 2 over x minus 1. So we do it again for limit for the point. Limit for the point. Our attention will be try substitute value dulu. Substitute what happened? 0 over 0 IDF again. So to solve this kind of IDF, okay, what make you 0, 0? When you substitute x equals to 1, it make you 0, 0, right? So your factor that make you 0, 0 is x minus 1. Whatever step of simplify, you must simplify boleh cancel factor that make you 0, 0, which is x minus 1. Right, so how to simplify this function here? When we have third function, we can try conjugate. So x plus 3 minus 2 over x minus 1, we time with its conjugate. The conjugate will be third x plus 3 plus 2. Limit notation still writing, and we try to simplify our conjugate. Denominator, do we need to expand at denominator here? No need, because we need x minus 1 to be cancelled, right? So you maintain this factor x minus 1. So time with this conjugate, we just write in the product form. Tulis dalam bentuk hasil dalam macam ni, jangan kembang. So at numerator, we try to expand so that you get x minus 1 to simplify 0, 0 to bottom. So simplify your conjugate. When you have a minus b times a plus b, so we get a square minus b square. This a square we get x plus 3 minus b square we get 4. So this one simplify we get negative 1. So x minus 1, that is the objective that we want to find. That is the thing we want to find. This x minus 1 can be simplified with the x minus 1 at the bottom. Then your 0, 0 dah disimplify. Dah potong. So no longer IDF. So when your function, having the function no longer IDF, then we can calculate again for the limit. Try to substitute atas ni 1, bawah 1 plus 3 plus 2. So 1 over 4. Same or not? No. Left hand side limit is negative 2. Right hand side limit is 1 over 4. So from here, we give out our reason. Limit x approaches 1 from the left when fx minus coordinate x minus 1. The fx minus coordinate x minus 1, it is not equals to the limit when x approaches 1 from the right when our function set x plus 3 minus 2 over x minus 1. So this function we can write in full 3 minus x squared. When this is not same, we can conclude that limit approaches 1 for the function minus the point over x minus 1, it will be does not exist. When this first principle for differential at a point does not exist, then we can answer the questions already. Are this function differentiable? No. When the limit cannot make it, therefore this function is not differentiable at x equals to 1.